Today, I will take you on a tour of the Sediment Core Physical Properties Measurement Laboratory. Underneath the International Expedition flags, this blue insulated shipping container is loaded with sensitive scientific equipment. Once inside, protected from the cold, we see Karsten Meyer-Jacobs from Germany preparing core samples for precise scientific measurements. To begin, a sediment core sample is placed on the bench. An electronic motor slowly pushes the sediment core down the rails and through the measurement stations, 1 centimeter at a time. The first stop in the row of instruments is the temperature sensor. The core temperature is precisely measured because the temperature may cause variation in other measurements down the line. Once the temperature is measured, the core moves down the bench to the P-wave transducers. This set of instruments performs several functions. The round cylinders on top measure the diameter of the cores. The transducers are the large round cylinders below. They produce seismic waves and measure how the waves travel through the sediment. The small metal tubes above drop water onto the core so the transducers will make solid contact. Here, the computer display shows variations in core diameter. On another screen, we can see the seismic waves. Notice how they change as the core moves down the bench. Finally, we get to one of the most important measurements being made in this laboratory: magnetic susceptibility. This white ring contains a sensing coil which measures the magnetic properties of the sediment. We have learned in previous lake sediment studies that the magnetic properties of the sediment are closely related to the climate conditions when the sediment was deposited in the lake. Strong magnetic measurements indicate times when the lake was warmer, and low periods tell about times when the lake was frozen over. After all the measurements are complete, the record of sediment cores on the drill rig is compared with the new measurements from the Physical Properties Laboratory. The cores are then prepared for shipping. To keep the lake sediments from freezing, they are loaded into styrofoam thermoboxes. On the day the helicopter arrives in camp, the thermoboxes are loaded for the flight back to Pivik, then later on to Germany and the United States. This is Tim Martin, 2009 Polar Trek teacher at Lake Elgiditkin in northeast Siberia.